Hi, my name is NAJWA binti NORAZUDIN and my number metric is 2019238326.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syairah ZAKIAH binti Muhammad ZAKI and my metric number is 2019448234. We are from CS 14348.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRA ZULAIKHA binti Muhammad ZUKKI. My student number is 2019203496. I'm from CS 14348A.
In this video, we would like to share about Newton's law of motion. Newton's law were verified by experiments and observation for over 200 years, and they are excellent approximations at the scale and speed of everyday life. In classical mechanics, Newton's law of motion are three laws that describe the relationship between the motion of an object and the force acting on it. Newton's law are applied to bodies which are idealized as single-point mass in the sense that the size and the shape of the body are neglected to focus on its motion more easily.
First is Newton's first law of motion. Newton's first law of motion is also called as law of inertia or law of balance force. Newton's first law of motion can be described as an object at rest will be stay at rest, and an object in motion at consistent velocity will be continue motion at consistent velocity unless at by some unbalanced external force. Relationship between mass of object and inertia is if a mass of object increase, the inertia will also increase. But if the mass of objects decrease, and the inertia will be also decrease. For example, if we compare the truck and the car, the moving truck will be harder to stop compared to the car. It's because the mass of truck was greater than the car. So, the car will stop first before the truck. Application Newton's first law of motion in real life. Now I will show you what happened when toys car in rest. The velocity for the car was 0. It shows that the things at rest will stay rest. Suddenly, unbalanced external force push it. What happened to the passenger in the car? The passenger will be jacked back when the car suddenly moves. It happened because of first law of motion. To reduce negative effect of inertia, in the car there are headrests to reduce net inject. But what happened when the car was in consistent velocity and no unbalanced external force? The car will still moving in same velocity. But if the car stops suddenly, the passenger in the car will jack forward. So it's important in the car they have seatbelt and airbag to prevent the passenger hit the dashboard.
Newton's second law of motion. Okay, now we will proceed with Newton's second law of motion. Newton's second law of motion can be stated as the rate of change of momentum of a body is directly proportional to the resultant force on it and is in the same direction as the resultant force. Newton's second law is represented by the expression resultant force F is equal to d over dt in bracket mv. If the mass m of the body is constant, then we can simplify the expression F equal to ma. Okay, now I will do an experiment. I have a car and a candle. I want to push the candle forward with the car. I apply a small force into a car, but the candle doesn't move forward. So I apply more force into the car, and the car is pushing the candle forward. Okay, now we will go more details about the equation F equal to ma. We know that the first law of motion, force are balanced, and the second law is force are unbalanced. Force unbalanced is acceleration. Acceleration is directly proportional to net force, and acceleration is directly proportional to 1 over mass. So from this statement, F is equal to ma. For example, we have mass is equal to 10 kg and its acceleration is 10 meter per second square. We will get the net force is 100 Newton. So from this we can define that 1 Newton is defined as the amount of force required to give a 1 kilogram mass and acceleration of 1 meter per second square. This second law of motion also happens to us in daily life. For example, when you push the trolley to enter the supermarket, your body will apply force to push the trolley forward. But when you push the trolley after you finish buying, your body will apply more force than the time you push the trolley before, because the groceries inside your trolley have mass itself that apply to mass of trolley. So your body need to apply more force to push the trolley forward. Second example, we know that the mass of ping pong ball and tennis ball are different. So a ping pong player need to produce less force than a tennis player to pass the ball at their opponent.
Okay, next we will discuss about Newton's third law. Newton's third law. What is Newton's third law? Actually, Newton's third law is about of motion that for every action there is an equal and opposite. Or we can say that if you give force on an object, it will give an equal force back to you. Okay, we have thus far considered force as a push or pull, right? However, if you think about it, you will realize that no push or no pull that occurs by itself. For example, when you push on a wall, actually the wall push back on you. Okay? For this example bring us to the Newton's third law concept. Okay, in the Newton's third law, whenever one body exerts a force on a second body, the first body experiences a force is equal in magnitude but opposite in direction to the force that it exerts. Mathematically, if a body A exerts a force on a body B, then B will simultaneously exert a force on A. Newton's third law represents a certain symmetry in nature. Force always occurs in pairs, and one body cannot exert a force on another body without experiencing a force by itself. We sometimes refer to this law loosely as a action and reaction, where the force exerted is the action and the force experienced is the reaction. Newton's third law has practical use in analyzing the origin of force and understanding which forces are external to a system. Actually, we can see many things happen in our daily life that are using or applying Newton's third law of motion. For example, you play a ball and hit it on the ground. They will exert a force downward. The ball will exert force downward, and the floor will exert an equal force upward.
Okay, now I will show you what happens when you place a toy car on the table. Okay, we can see that when car hits the tables, the car exerts a force on the table, and the subject exerts an upward force on the object. So, there are two forces that we get from this interaction. Okay, now we can see where the magnitude of the two forces are the same, but the direction are opposite. The forces are called as action and reaction force. The force exerted by the car on the table was an action force, and the force exerted by the table on the car is the reaction force. So, this is the example of Newton's third law of motion in our daily life. That's how simple the third law is, where every action has an equal and opposite reaction.
That's all from me. Thank you.
Newton's first law, we can see that everything will be stay at same position if there are no another force add on it. It because of inertia. For example, a runner who run in consistent speed difficult to stop at finish line it because of this law. Why Newton's second law of motion referred to acceleration of an object is directly proportional to next force and inversely proportional to its mass. For example, tennis player and ping pong player receive different force. Newton's third law talk about for every action there are an equal and opposite. It is like if you give force on an object, give an equal force back to you. To summarize all the video, we can see there are three types of Newton's law of motion, which is first, second, and third. All of three Newton describe about the relationship between motion of the object and the force act on it.